So just a couple more examples of being able to work with these inverse trigonometric derivatives. So we have this function where y is equal to 6x times the arc sine of x. And what we'd like to do is we'd like to be able to find the derivative of this. And notice this is a product rule problem. All right, so we have two functions. So I'm going to call little f 6x, and I'm going to call little g arc sine of x. Now we know the derivative of 6x is just 6. And what we can do is we can go and remind ourselves the derivative of arc sine is 1 over the square root of 1 minus x squared. And we could use our product rule. Remember, product rule is f prime g plus f g prime. And so our derivative dy dx is going to be equal to 6 times the arc sine of x plus 6x times 1 over the square root of 1 minus x squared. Or another way, if you choose to write it as such, is you could factor out a 6, and you could write this as the quantity of arc sine of x plus x over the square root of 1 minus x squared. Right. And so in our last example, we just want to find the derivative of an arctangent function with a composite e function. All right, so this is actually a really sneaky problem. It's not too difficult, but notice that we have a chain rule. And so we remember that the derivative of the arctangent is going to be 1 over 1 plus x squared. And we saw this earlier to where students often make mistakes, is they might just write this as 4, and this, I'm sorry, this would be the derivative. So it's not just 4, but it's f prime of x is equal to 4 times 1 over the square root, or 1 over 1 plus x squared, but that's not correct, right? Remember, x is whatever's inside of that parenthesis. So in this case, f prime is going to be equal to 4 times 1 over 1 plus e to the 8x squared. But it's a chain rule problem, so we have to multiply by the derivative of e to the 8x. And so if we go through and expand this, and this is a prime, excuse me. If we go through and expand this, we're going to get 4 over 1 plus e to the 16x. All right, so notice we square, we multiply. Now the derivative of e to the 8x is a chain rule again. So this is going to be, the derivative of e is e to whatever it is, but then we also have to take the derivative of the 8x. And we know that the derivative of 8x is going to be 8. And we can just multiply the 4 and the 8 together. We can put that e to the 8x in the numerator. And so our final answer for this derivative, f prime of x, is going to be 32e to the 8x. And then we're going to divide that by 1 plus e to the 16x. We can't simplify that any further. Right, so this is going to be the final answer that we get from that derivative of the trig function. All right, so hopefully this gives you a basic overview of the inverse trigonometric derivatives, how to work with them, and hopefully seeing how to work with them to avoid some of the common pitfalls.